These are your 5-3 notes on solving multi-step inequalities. We're going to take the strategies from 5-1 and 5-2, adding, subtracting, multiplying, dividing to solve inequalities, but we're going to combine them. So today is just sort of mixing up several different forms. So they get a little bit more difficult, but it's the same concept. You're going to use inverse operations to solve. So a couple of things to remember. You want to distribute if there's parentheses, clean up, combine like terms if necessary. So you want to clean up the sides of the inequality. If there's a variable on both sides, you want to get them on the same side if necessary. And I'm going to say get it to the left. Move the variable to the left side. That way when you answer your inequality, you always have x in terms of x is less than or greater than or equal to some number. So it's not necessary, but it's so much easier if the variable is on the left-hand side. Then you're going to use the inverse operations to isolate. Remember, you're undoing the problem, so whatever happened to the variable last has to be taken care of first. So it's kind of like an inverse order of operations. And then pick numbers from the solution to check. You can always pick a number, plug it in, and see if it works. All right, so we're going to solve 13 minus 11d greater than or equal to 79. I like to describe what's happening to my variable. Right now, it's being multiplied by 11, or a negative 11, and then we're adding 13 to it. So the very first thing we need to take care of is we need to move the 13, the stuff farthest away from the variable. So I subtract 13 from both sides. Don't lose that negative. It's a negative 11d greater than or equal to 66. And then I'm going to divide by a negative 11, divide by a negative 11. I'm dividing by a negative. So my value is going to flip. D is now less than or equal to negative 6. Put it in set builder notation. And then on the number line, I'm going to put negative 6 on my number line. We're going to put a closed circle at negative 6. And then these are the numbers that will work, that will satisfy the original inequality. And I haven't shown you this, but to check our solution, you can sort of check your solution. It won't guarantee that you're right, but if you get a wrong answer, then you know it's wrong. To check that negative 6 is really the cutoff, you can plug negative 6 into the original. So if I plug negative 6 in here, I should get equals to 79. And so 13 plus 66, does that equal 79? And it does. Okay, so 79 is equal to 79. That tells me that negative 6 is the right number where this starts. It doesn't really check the shading. So to check for shading, you've got to pick a number somewhere in this region. So an easy number to use would be like negative 10. Negative 10 is less than negative 6. So if I plug in negative 10, I'm checking, is that going to give me something greater than 79? I already checked the equals part of 79. I want to know, will I be greater than it? And 13 plus 110, greater than or equal to 79, and that's true. 123 is greater than 79. So this is a true statement that tells me that I'm shading in the right way, and that I started shading from negative 6 is the correct number. You don't have to check. I just wanted to go over that with you so you have that as an option. For number 2 here, we're going to distribute before we can do any inverse operations. So we got to get rid of these parentheses. So 6 times 5x is 30x. 6 times negative 3 is negative 18, less than 36x. Now typically in an equation, I would move the 30x over to the 36. We can do that, but then I'm going to change it around. So I'm going to do that because the 18 is over here. So I'm going to subtract the 30x. Cancel that out. Negative 18 is less than 6x. But when I solve, I still like to solve where my variable is on the left-hand side. So I'm going to take a moment to switch these around. But I want to mention, when you switch terms around with an inequality, if I just switch this, if I put 6x over here and negative 18 over here, and I don't switch my inequality, in the original inequality, I'm saying that negative 18 is less than 6x. And so I got to make sure that negative 18 is still less than 6x. So I actually have to flip the inequality. I'm flipping the inequality to maintain its value. All I wanted to do was change sides. In an equation, it doesn't matter. But in an inequality, if it was pointing to negative 18 in the original, I needed to still be pointing to negative 18 when I flip them. It's not necessary that you change signs and put the variable on the left, but it's so much easier. So I'm going to divide by 6, divide by 6. It's a positive 6 that I'm dividing by. So x is greater than negative 3. Put it in set builder notation. And as a graph on the number line, that's going to be an open circle at negative 3. And the values greater are to the right. Here's one of the advantages of putting the variable on the left-hand side. If you notice the direction I shaded, it matches sort of the arrow in which the inequality looks like. It's pointing to the directions, the area with which you have to shade. It only does that if it reads x greater than negative 3. The other advantage of having x on the left-hand side is then to put it in set builder notation, it's already set up for you that way, so you won't make errors when you try to report your numbers and your answers. Okay, just trying to give you a few more problems here to try. So this one we have to distribute the 2 on the left-hand side and distribute the negative 3 on the right-hand side. So 2 times m is 2m, plus 2 times 6 is 12, greater than negative 24 plus 3m. Now I have numbers and I have variables on both sides. I'm going to pose to you the idea of bringing the variable over to the left, minus 3m. Even though it's going to be negative, I'd rather have it on the left-hand side. And at the same time, if you're ready for it, we could also bring over the negative 12. And so what I'm doing in this one step, we used to take 2 steps with, but I think if you're ready, we can do that all in one step. So the idea is that this number is going to show up over here, and the 12 is going to show up over here. So we're getting variables on one side, numbers on the other. So when I go through this problem left to right, I have a 2m, take away 3m is a negative 1m. My 12 and negative 12 cancel. Greater than negative 24, take away 12 is negative 36. And the 3m and the negative 3m cancel. So I'm going to divide by negative 1. Divide by negative 1. M is going to be now less than positive 36. I have to flip the inequality because I divided by a negative 1. Put your variable out in front, set builder notation. For my number line, I'm going to have an open circle at 36, and I'm going to shade to the left. These are all the numbers that are less than 36. They go to the left. In number 4 here, for number 4, I want to solve, and these sometimes lend themselves to be a little difficult. So people want to get rid of the 3 first. It's actually better if you put parentheses around this quantity, and we're dividing by negative 4. So if we multiply by negative 4 and then divide by negative 4, it's like it never happened. They cancel each other out. The multiplication of negative 4 and the division of negative 4 cancel each other out. If we multiply the one side by negative 4, we also have to multiply the right side by negative 4. So I'm left with x plus 3 greater than or equal to negative 8. We multiplied by a negative, so it flips the inequality. We're going to subtract 3 from both sides. X is greater than or equal to negative 11. And there's your solution in set builder notation. When I make my line, my number line at negative 11, I'm going to have a closed circle at negative 11, and my answers are going to be to the right. A little bit of the writing these things, it's just a little bit more complex, but just like we did before, you read the words and you replace them with symbols and numbers. 4 times a number, 4n, plus 12 is less than the number, which is my n, minus 3. The number minus 3. So I got variables on both sides. I got numbers on both sides. Let's bring this n over. So I'm going to subtract n from both sides. And in the same step, if you feel comfortable, subtract 12 to bring it over with the negative 3. If you don't feel comfortable with that, in the next step, you would just subtract the 12 separately. 4n take away n is 3n. Cancel out the 12 and the negative 12. less than negative 15. Divide by negative 3, divide by negative 3, or by 3. N is less than negative 5. I didn't have to flip my inequality. Even though 15 was negative and my answer is negative, that has nothing to do with it. It's the fact that I multiplied by positive, or I'm sorry, I divided by positive 3's, and so that doesn't change the inequality. Put it in set builder notation. Graph my solution on the number line. So there's my negative 5. It's going to be an open circle at negative 5, and the values to the left are less than negative 5. That's it. So what I'd like you to do, I need you to write an inequality. Oh, that's bad English. For to represent. I need you to write an inequality to represent 2x plus 5 less than or equal to x minus 7. So put that in words. You might want to refer to your 5152 notes. I gave you a lot of words that you can use for the inequality. And then solve that particular inequality, graph it on a number line. Good luck.